All right, so a question based on these 5 destructive effects of a nuclear explosion. Which is the most destructive? Think about that for a second. You would think it would be the fireball or the blast wave, but the reality is the most destructive is the radioactive fallout. There are about 32,000 nuclear warheads in the world, enough to destroy the world several times over. And the way it's enough to destroy the world several times over is because this radioactive nuclear fallout it's what would get the people who are not killed in the initial explosions. All right, so classifications of the sizes of these nuclear monsters. Kiloton is 1,000 tons of TNT. So the first bomb dropped, little boy, was 15 kilotons, or about 15,000 tons of TNT going all off at the same time. Of course, having those extra effects of the nuclear explosion. Fat Man was just 6 more than that. So today, our small bombs are 1,000,000 tons, or a megaton. A megaton is 1,000 tons of TNT. So 1,000,000 tons of TNT, or 1,000 kilotons. So a megaton is 1,000,000 tons of TNT. So today, a typical size of nuclear weapon is 20 megaton bombs. We have 50. The Soviet Union even developed a 100 megaton bomb. Just massive bombs that can just, Los Angeles, 30 miles on either side, just be wiped out from one of these 50 megaton bombs. Now, so how is it that all what's packed in that warhead that's really relatively small can do so much damage? It is because of this right here. This is how a nuclear bomb works. Now, if you look at this, and I realize you can't see this right here very well, but it says there's one neutron right here. So all the nuclear devices, you've got this mass of enriched uranium, about the size of a grapefruit, maybe a little bigger. And there's a little machine that sends in, at the critical moment, sends in one neutron into this critical mass of enriched uranium. This neutron, when it hits its first atom, will split the atom. When the atom splits, there's 3 neutrons in that atom. Those 3 neutrons will then go and hit 3 more atoms. So in the second generation, now you got 9 neutrons flying about. And then in the next generation, you've got 27 neutrons flying about. And this happens instantaneously. For all intents and purposes, this happens instantaneously. So once that first neutron hits, it takes less than one second to reach this critical mass of this reaction. And then there's a machine around this critical mass that pushes it inward, pushes that mass inward. And when it gets pushed inward, this chain reaction fights back. And when it fights back, it pushes outward. And that's what makes the nuclear explosion. It's really that simple. It's so simple, it's scary. Now, so let's show you, in today's world, what could happen here. What could happen with this nuclear explosion. So this is the city of Los Angeles, the Los Angeles view. So let us drop little boy on that view. And so what you see here are these various rings. So here's the initial nuclear radiation, etc., until you get to the furthest effect. So you know that those of you who know the area, if you were to drop a nuclear weapon on downtown Los Angeles, you'd see it come out to the 5 over here, come over to the 110 over here. I think this is the 60 or yeah. So it's a good amount. It's a good amount for one bomb. But remember, that's just a little boy. So let's go with a little bigger. Here's Fat Man. And so you can see with the 6 more kilotons, it goes out a little farther. Goes a little farther, but still a relatively small bomb. Now, 1.4 megaton bomb. Wow, you can see that this thing goes far beyond. Here's where the little boy and Fat Man went to, right about here. This goes far beyond that. Far beyond that. But again, a 1.4 megaton bomb is relatively small today. So let's nuke it with a 10.5 megaton bomb. And you can see here it's going all the way out here past Arcadia, these destructive effects. But again, this is a relatively small bomb. So let's nuke it with, well, let's give you a bigger view of that. So you can see here that this 10 megaton bomb would reach clear to Glendora. Just one bomb. One bomb. Now, what if we nuked it with a 50 megaton bomb? Wow. Glendora, we're past Glendora, past Pomona, past Ontario. On the other side, you can see how far we've gone out. There's San Fernando Valley, Santa Clarita, etc. Let's give you a larger view of this 50 megaton bomb. You can see how far this 50 megaton bomb goes out. That is why we have given the president so much more power than he once had, because of the ability of nuclear weapons to just wipe us all out. We look at the coronavirus, the president has extraordinary power relative to that because of the threat. So you can see here this instantaneous threat. And so because of that, we have given the president this life and death ability to make those decisions for us, whether or not we'll fire back. This idea that we will fire back and the other side will fire back is known as MAD. M-A-D. What MAD stands for is mutually assured destruction. This is a question on the test. Not that I intended to put this at the end of the video, but this idea of MAD, that if we fire a weapon at them, they'll fire back at us, full response. We cannot win a nuclear war. That's the assumption. So if you can't win a nuclear war, why fight it? So this idea of MAD has literally kept us out of nuclear war since after World War II, and that's where we're at today.